Hello, my name is Mark, and this video lecture is about rationalizing denominators. Okay, and rationalizing denominators, what that really means is we don't want any radicals in our denominator. And the way you get rid of a radical in the denominator is you have to multiply by something that's going to cause a perfect root of whatever that root is. So let's look at this first one. Okay, you see we have 1 over the fifth root, 1 over the square root of 5. So what we want to do is we want to create a perfect square because it's a square root. So if you have a perfect square, you want to create, you have a square root, you want to create perfect squares. If you have cube roots, you want to create perfect cubes. If you have fourth roots, you want to create perfect to the fourth power, and so on. So right now we have a square root, so we want to create a perfect square. Okay. Well, in order to get a perfect square, what I do is I multiply by some number that's going to cause a perfect square in that radical. And whatever I do to the numerator, I have to do to the denominator. So I'm going to multiply by the square root of 5. Okay, and if you think about it, if you multiply by the square root of 5 over the square root of 5, that's just 1, because anything over itself is just 1. Okay. And look what happens when I multiply. Well, 1 times the square root of 5, that's just the square root of 5 in the numerator. And the square root of 5 times the square root of 5, well, that's the square root of 5 squared, because 5 times 5 is 5 squared. And the reason why I'm writing 5 squares is just to put the emphasis that you have a perfect square under square root. What happens when you have a perfect square under square root? Well, it just becomes itself. And see, I no longer have a radical in my denominator, and that's my goal, because when I rationalize a denominator, I want to get rid of that radical. And so I have to multiply by something that's going to cause a perfect root. So once again, let's look at this next one. Let's look at the next one. 1 over the cube root of 3. Okay. So what do I want here again? Well, since I have the square root, it's 1 over the square root of 3. Since I have a square root, I want a perfect square. So what number can I multiply to get a perfect square under this square root? Okay, if you said the square root of 3, you're on the money, and then it's just pretty much what we did last time, in the last problem. So 1 times the square root of 3 is the square root of 3. And the square root of 3 times the square root of 3 is the square root of 3 squared. And the square root of a perfect square is just itself. Okay, let's look at the next one. 1 over the cube root of 3 cubed. Okay. Well, when I had a square root, I wanted to create perfect squares. So guess what I'm going to try to create if I have a cube root? I'm going to try to create perfect cubes. So I have to ask myself, what do I need to multiply 3? And if you think about it, this is really 3 the first. What do I need to multiply 3 by to get a perfect cube? Well, I multiply it by 3 squared, so I'm going to multiply top and bottom by the cube root of 3 squared. And the reason being is because the square root of 3 times 3 to the first gives me 3 to the cube, and that creates a perfect cube. So once again, looking at bottom, I have the cube root of 3 cubed. Well, the cube root of a cube is just itself. And voila, I have my goal. I no longer have any radicals in my denominator. Let's look at those next two. Well, if I have a fourth root or a fifth root, what do I want to do? I want to create perfect roots. So in this next one, I'm going to multiply by something that's going to cause me what? A perfect fourth power, because I have 1 over the fourth root of 3. okay, and the fourth root of 3 to the third, times 3 to the first is 3 to the fourth. I have a fourth power under a fourth root, so that just becomes itself. Okay, and 3 to the third is what? Well, 3 to the third is 27. And I probably should have done it on the previous one. 3 squared is 9. Okay, we're back in business. Now let's look at this last one. Well, it's going to be the same thing. I have what? I have the fifth root of 3, so I need to multiply by something that's going to cause me to have a power of 5, so I'm going to probably multiply by the fifth root of 3 to the fourth power. Okay, and then when I do the bottom, the fifth root of 3 to the first times the fifth root of 3 to the fourth equals the fifth root of 3 to the fifth in the denominator, the bottom. Okay, and then 1 times the fifth root of 3 to the fourth is just the fifth root of 3 to the fourth. So if I have the fifth root and 3 raised to the 5 under that, that's just 3. And then 3 to the 4, that's 81. And there we have it. So remember, when you're trying to rationalize your denominator, you're trying to create a perfect root in the denominator, okay, into the radical in the denominator. So if you have a square root, you're trying to create perfect squares. If you have a cube root, you want to create perfect cubes. So this has been my video lecture about rationalizing denominators. You can look me up on the web, www.supergenius99.com. Thank you for listening.